Hello, and welcome back to our studies in physics. You'll recall from the intro video that we discussed what physics entails. What we'll be up to this semester is just an overview of the field of physics. And we determined that we're going to zero in on two subcategories within physics, those two subcategories being mechanics and thermodynamics at the end of the semester. So mechanics is the subcategory of physics that we will be really zeroing in on for the first approximately 2/3 of the semester. Mechanics itself can be split into two subcategories, as we spoke about in the earlier video. Kinematics, which is the study of an object's motion, and kinetics, the study of the causes or reasons for an object's motion. So in chapters 2 and 3, we're going to be looking at kinematics. The study of an object's motion. What kind of quantities do we need to be able to use to be able to describe an object's motion? And subsequently, we want to be able to see how these quantities are related to one another. Things that we will need to be able to precisely define in order to be able to fully and precisely describe an object's motion are things like position. Where is the object located at a certain time? Where in space? And you know that we will need some kind of a coordinate system to describe the position relative to some origin that we will determine as we go along. So position. Another quantity that we will need to fully understand and be able to use is displacement. Displacement is a quantity that is the final position of an object minus the initial position for the object. So if we say that an object is only moving in one dimension, in other words, it can only be confined to move along the x-axis or the y-axis, or for example, just along north-south, that would be like traveling along I-25, or just east-west, like traveling along I-40. If an object is just confined to move along a line, then we can define that position as just some x naught. This little sub O, this is spoken as x naught. These little sub O's are initial positions. So this is an initial position, okay? Where a final position normally doesn't have any subscript following it. And different textbooks have different nomenclature, but for our purposes, we're going to say x is equal to the final position for an object, okay? So displacement then is going to be the change in the position, right? Final position minus initial position is change in position. And this change in, anytime we use these words change in, we're going to use a Greek symbol to keep track of these letters. And that Greek symbol is the delta symbol. Okay, it's a triangle. So change in position, we're using the symbol X for one-dimensional motion. Again, that's just moving along the x-axis, or just the y-axis, or just north-south, or just east-west. So the change in the position then is going to be some final position, which remember we just are using x without a subscript, minus the initial position, which we give the little subscript not to x naught. Okay, so displacement, final position minus initial position, we took a sentence and put that into a mathematical equation. So we now know how to define position, we know how to define displacement. What other kind of quantities are we going to need to be able to describe motion? Well, what about distance? distance isn't the same thing as displacement. Let's give distance the symbol d, and this is just the total ground covered. And you say to yourself, well, how are distance and displacement different? Well, imagine that you are at a football stadium and there's a track that goes around the football field itself, and we know that those are quarter-mile tracks. And if you start at one location on the track and you complete a full loop around the track so that your initial position and your final position become the same after one complete loop, then your displacement or final position minus your initial position is going to be 0. You are ending up where you started, and so your displacement is 0. But what about the total ground you covered? Well, the total ground you covered is the quarter mile. So anytime your direction changes, the distance and the displacement for the object will not be the same. If the object continues moving in one direction and never turns around, that is the only case in which you will find that distance and displacement are indeed the same quantities. So this gives us a way to quantify the location of an object, how it moves from one position to another, and the total distance that it was covered. And I think this is probably good for a start on kinematics. Let's see how we can use other quantities to fully describe an object's motion in the second part.